The diagram shows a semicircle of radius r inside a right-angled triangle. The shorter edges of the triangle are tangents to the semicircle. So these are the tangents to the semicircle and have lengths a and b. The diameter of the semicircle lies on the hypotenuse of the triangle, and we need to prove that 1 out of r equals 1 out of a plus 1 out of b. So one thing we do in this question is, though we attempted to use Pythagoras, we don't use Pythagoras. We use the area. Okay, so now how do we use that? So what I would do is, if I were to join the center of the semicircle to the tangent, draw a line from the center to the tangent. So that would be the radius, and another radius, and radius is perpendicular to the tangent. And you see, then I can say these are both r, and also the tangents drawn from an external point are equal. So if we are to call this A, B and C, and if this was O, then OA equals OC, and AB equals BC. Tangents drawn from an external point are equal, and this is radius. Now you see three angles are 90 degrees, so which would mean angle AOB 90 degree. All three angles in OABC are 90 degree. Three angles in OABC equal 90 degree. So fourth angle is also equal to 90 degrees. And then we can say that adjacent sides are equal. OABC is a square. And all the angles are 90 degree. So we can say angles are 90 degrees. So if OABC is a square, then AB would be equal to R and BC would be equal to R. So therefore you can say the other bit is, if I could say, name it, whatever, Mn. So if this was M and N, so we could say that MA equals B minus R, because the entire length is B, so that's B, so we can say it's B minus R. And then you can say that Cn is equal to A minus R. So we now find the area of these three parts. We can easily do that because we have all of these as right angle So area is half times base times height. So area OMA plus area OABC plus area OCN equals area of the large triangle, which is MBN. Okay, so I should say triangle MBN. So these are all, this is triangle, square, triangle, triangle. Okay, but I think it's self-explanatory. So I will write the areas. Area of OMA is half times base times height. So MA is B minus R. So this was B minus R multiplied by R plus area of the square is R square, and the triangle OCN would be half times B or A minus R times R. Excuse me. So then that would equal area of MBN, the large triangle, so that's half times A times B. So we can remove the brackets, and then it would be half BR minus half R square plus R square plus half AR minus half R square equals half AB. So then half R square, half minus half R square would give me R square. So R square minus R square is 0, so we cancel those out. So we are left with half BR plus half AR is equal to half AB. So we cancel the halves out. So we have BR plus AR equals AB. Now I can divide it throughout by ABR, ABR, and then ABR, and then dividing throughout by ABR. So then we get, therefore, you would cancel the BR, so 1 out of A plus AR gets cancelled, so 1 out of B is equal to 1 out of R, and hence we got our proof. So we can write it the other way, bring 1 out of R to the left hand side. So we've proved it.